We see in this picture two lines, line M and line N, and they're being crossed by line T. So when that happens, when you have two lines that are crossed by a third line, then that line that's going across them is called a transversal. Right? So I labeled it as T to kind of represent transversal. So let me just write transversal there. It's a line that crosses two or more other lines. Now when this line crosses these two lines, you can see it creates 8 angles that I've numbered here. 1, 2, 3, 4, 5, 6, 7, and 8. 8 different angles created in this situation. We can group pairs of these angles in certain ways so that they have a certain name that describes them. For instance, in this picture, there are 2 pairs of same side interior angles. So the same side part of this name refers to the fact that they're on the same side of the transversal. So I kind of oriented this transversal somewhat vertically. So both of the angles I'm talking about here are on maybe the right side of the transversal or maybe the left side of the transversal. It also says that they're interior angles. So that indicates that they're in between the other 2 lines, M and N. So if I think about that name, I'm looking for a pair of angles that are both on the same side of the transversal and they're between the interior angles. That looks to me like it would be angle 3 paired with angle 6. Angle 3 and angle 6. They fit the qualifications for the same side interior angles. There'd be another pair right here, angle 4 and angle 5. Also on the same side of the transversal, in this case they're both left of the transversal, and they're in the interior, which means they're between the 2 lines M and N. So those are called same side interior angles. There's also pairs called alternate interior angles. So you can see it shares the interior part with this one up here, but now it says alternate. And what that indicates is that they're not on the same side of the transversal, but they're on opposite sides. So angle 3, which is on the right side of the transversal, would get paired with angle 5, which is on the opposite side of the transversal. Some might think, well, would you pair angle 3 and angle 4 together because it seems like they fit the definition? And one of the things you got to recognize is that when we're making the pairs of angles that we're describing here in this section, we're picking one angle from like this group of 4 and then another angle from this group of 4. So angle 3 would get paired with angle 5 for alternate interiors. Angle 4, in this case, would get paired with angle 6. Again, alternate sides of the transversal, one on the left, one on the right, and in the interior space, which is between the 2 lines. Corresponding angles are called corresponding because they are in corresponding or matching positions. So for instance, if I look at angle 3, we'll start with angle 3 again, and I notice that angle 3 is like in the lower right-hand corner of these 4 angles, right? Upper left, upper right, lower left. Angle 3 is in the lower right-hand position among these 4. If I move down to this group of 4, the angle that's in the matching position, lower right-hand corner, would be angle 7. So we say that angle 3 and angle 7 are called corresponding angles. If I move back up here and I look at angle 2, it is in the upper right-hand position, just like angle 6 down here. So angles 2 and 6 would be corresponding. Angle 1 is in the upper left-hand position. And if I move to the other grouping of 4, angle 5 is in the upper left-hand position among that group. So they're corresponding. That looks a little too much like a 6. Let me rewrite that. Angle 1 and angle 5. And then angle 4 is in the lower left-hand position, and so is angle 8 down there. So angles 4 and 8 are corresponding angles. Lastly, we have a grouping called the alternate exterior angles. So it's kind of like alternate interior, except for we're moving into the exterior part of my diagram, which would be outside the 2 lines. So not this interior space in here, but the exterior spaces that are below line N in this case and above line M. So for instance, if I look at angle 1, It is on the left side of the transversal and on the exterior. And then I move to the other group, and I'll be looking for the angle that's on the opposite side, so over here, and on the outside. That would be angle 7. They're a group called the alternate exterior angles. Angle 2 up here is also on the outside of the two lines being crossed by the transversal, but it's on the right side. If I move down to this group down here, angle 8 is on the left side of the transversal and in the exterior. So angles 2 and 8 would be considered alternate exterior angles. So these are our pairs of special angles that are created when a transversal crosses two lines. Now, if something special happens where line M and line N are parallel, so this would be parallel to this, right? Line M and line N are parallel. When that happens, there are some special relationships among these groupings. So let's start with the same side interiors, angle 3 and angle 6. When these lines are parallel, the same side interior angles, so I abbreviate this same side interior, SSI, same side interior angles are supplementary. Remember, that means they add up to 180. So I can say, therefore, the measure of angle 3 plus the measure of angle 6 would equal 180. And I could say that the measure of angle 4 plus the measure of angle 5 equals 180. And this is called the same side interior angles postulate. I'll jot that down over here. This is called the same side interior angles postulate. So it's a postulate, meaning that it always happens to be true, although we can't necessarily prove that it will always be true. We just kind of generally accept, hey, look, it seems like it's just always true. So we'll just say it's a rule. We call that a postulate. Now, if I move down to the alternate interior angles, we can think about this for a second. Because let's imagine that angle 3 was perhaps, maybe this looks like about 110 degrees, right? That would mean that angle 6 is going to be 70 degrees, because we know they have to add up to 180 according to what we just talked about, since these lines are parallel. Now, I would know that angles 3 and 4 should also add up to 180 because they're a linear pair. And so that would make angle 4 be 70 degrees. And now you'll notice that angles 4 and 6 are both 70 degrees. If angle 6 is 70 degrees, then angle 5 would have to be 110 because these two are a linear pair, and that means they're going to be supplementary. So if I notice that these pairs, 3 and 5, are both 110, 4 and 6 are both 70 in this hypothetical example I created, it seems to me like the alternate interior angles are going to be congruent. So therefore, in this picture, the measure of angle 3 will always equal the measure of angle 5, and the measure of angle 4 will always equal the measure of angle 6. And so this is called the alternate interior angles theorem. And it's called a theorem this time because if we assume that the same side interior angles are going to be supplementary, then we can prove, kind of like what we just did, we can prove that if these are going to be supplementary, then angle 3 and angle 5 have to be congruent, because angles 3 and 5 would both be supplementary to angle 6. And we learned in a previous section that when two angles are both supplementary to the same angle, they have to be congruent. And then angle 4 would be the same situation. Angles 4 and 3 would have to be supplementary, angles 6 and 3 have to be supplementary, and so since 4 and 6 are both supplementary to angle 3, they have to be congruent to each other. So that's how we kind of know that the alternate interior angles will always be congruent. Now if we move on to corresponding angles, let's use this hypothetical situation that we already have set up here. I know that angle 3 is 110, angle 6 is 70, angles 6 and 7 are going to be supplementary, or I could say that angles 7 and 5 are going to be congruent because they're vertical angles. Whatever the case might be, whatever reason I might be looking at, I know that angle 7 is going to be 110 degrees. And now I look at angles 3 and 7, it looks like they're both 110. If I look at angle 8, it's going to be congruent to angle 6 because they're vertical angles. So that's 70 degrees. Angles 4 and 8 were corresponding. It looks like they're both 70. Up here, angle 2 is going to be 70 because it's a vertical angle with angle 4. And now angles 2 and 6, which were corresponding angles, they're both 70. Angle 1 is going to be the same as angle 3 because they're vertical angles. And now look, angle 1 and angle 5, the corresponding angles here are both 110. So it appears that if the lines are parallel, then my corresponding, C-O-R-R, corresponding angles are going to be congruent. And that one is called the corresponding angles theorem. So I would know in this picture, therefore, since the corresponding angles are congruent, this little symbol, by the way, it means therefore. That little triangular arrangement of dots means therefore. Therefore, I know that the measure of angle 3 in my picture here equals the measure of angle 7. I know that the measure of angle 2 equals the measure of angle 6. I know that the measure of angle 1 equals the measure of angle 5. And I know that the measure of angle 4 equals the measure of angle 8. Lastly, we move on to the alternate exterior angles. Now, I've already labeled everything that I know about this picture. Again, I assumed, or I kind of started with a hypothetical situation that angle 3 was 110. And off of that, we figured out all these other angle measures. Well, let's look at the alternate exteriors, 1 and 7, angle 1 and angle 7. Hey, look, they're both 110. Angles 2 and 8, looks like they're both 70. So I'm going to say that when the lines are parallel, the alternate exterior angles, AE for alternate exterior angles, are congruent. So we call that the alternate exterior angles theorem. And so I would know that in this picture, the measure of angle 1 is always going to equal the measure of angle 7, and that the measure of angle 2 will always be equal to the measure of angle 8. So again, we learned in this video that a transversal is a line that crosses two other lines. When a transversal crosses the two lines, it creates these 8 angles. We can pair up an angle from here with a certain angle from here as maybe a same side interior angles pair, or maybe an alternate interior angles pair, maybe a corresponding angles pair, or maybe an alternate exterior angles pair. And we've listed those out. Then we realize that if the lines are parallel, some of these things have special relationships. They actually all have a special relationship to each other. The same side interiors are going to be supplementary. Then the other pairs, the alternate interiors, the correspondings, and the alternate exteriors, they end up being congruent to each other.